This is the turbo version of the oscilloscope, capable of running up to 239 kHz. I'm going to capture the port first. I'm going to set the PWM wave operating. I'll set a trig level now. I've connected a signal generator and I'll try just a simple one-off run. I can at this stage estimate the frequency of the signal. It's possible to copy the graph. It's also possible to copy the data. I can do a continuous run. With trigger in operation, it's holding the signal. By default, it's triggering on a positive edge. I can now ask it to trigger on a negative edge. Let's try altering the frequency of the signal generator. Okay, that's lower. Whilst it's running, I can freeze the graph and get some information on it. Data is continuing to be sent from the Arduino. I can unfreeze the graph and it will continue. Let's up the frequency. I'm going to stop the signal. And I'll stop the capture. Now the reference voltage that the Arduino is operating on happens to be 4.75 volts. So I'll alter it so it'll rescale to 4.75 volts. I'll now send that information to the Arduino. So I've restarted the capture. I'll send that reference voltage across. So the Arduino now knows that its supply is 4.75 volts because I've measured it. It's supposed to be 5 volts, but that's what my USB outputs. I'll reset the trig level. Okay. Well, because we'll reconnect, we have to tell it again to set up a test signal. So now, rather than use the signal generator, I'm going to connect PW3, that's the pulse width modulated signal on port 3, to my input. If I now run this, that's the signal, not from my signal generator, but it is from the pulse width modulated signal that the Arduino is producing itself. I'll freeze that, I'll get the frequency. If I now scroll down here, I can show you that the default frequency on a Mega is around about 490 Hertz, which is, not surprisingly, what the oscilloscope is reading. Unfreeze the graph. Pressing select on the Arduino would stop the capture. I'll run it again, and this time I'm going to try altering the delay that takes place between readings, effectively altering the time base. Prescaler of 8, 16, 32, 64. Notice how the time base is changing at the bottom. $128. Inverting the triggering causes, of course, the signal to commence on a negative edge. And that's it.